Hello everyone, how are you? Good evening to everyone. So we are here with our revision series of current electricity, and today we are going to revise the some concept of important concept of current electricity. And obviously we are going to see some PYQs from JEE Main and NEET. So this is a very important chapter for JEE Mains and NEET both. Although the syllabus has been reduced from this chapter, so weightage of this chapter is quite high in the examination. And also this is a very conceptual yet very interesting question. Very interesting chapter, I think. I see. So let's get started. So the very first topic that we are going to deal about, and the topics that we would like to cover for today, is the VI characteristics of ohmic and non-ohmic conductor. Firstly, we will see what is ohmic and non-ohmic conductors are. Okay. After that, we are going to learn about some electrical energy and power. What is that? Basically, we are going to see the formula of that and from where it comes and what is the use of that. Now, then after we are going to learn about electrical resistivity and conductivity. Obviously, current density it also include. Then temperature dependence of resistance and resistivity both. After that, we are going to cover some electrical devices, galvanometer, ammeter, and voltmeter. And from each of the topic, we are going to see some PYQs. So it will be helpful for you guys to relate it with the same concept. Okay. So firstly, in this chapter, if I talk about what is current, because it is the name of this chapter is itself is current electricity. What is current? Before this chapter, what we are dealing with, we are dealing with a charge which is not moving. We are dealing with a static charge. That is why the study there that we have done is called electrostatic, which means this study of static charge distribution. But here in this, if you are talking about current, current mean flow of charge, which means here the charge itself is in motion. So in this chapter, we are going to deal the charge in motion. Now, whenever the charge will come in motion, so there will be a flow of charge. The rate of flow of that charge to a particular from a cross-sectional area, let's say this is a cross-sectional area of A, and charge entering at this area or crossing this area in time delta t is delta q. So this much charge has crossed this cross-sectional area in this time. So what is the current? Current is defined as the rate of change of flow of charge per unit time. This is current. Now for that, you always remember this current should be the charge that is flowing should be perpendicular to the cross-section area. Okay. Suppose there is a distribution like this. So we will not take this area. The area vector of this will be in this direction. The component of this area in perpendicular direction, which is this area we are going to take as the area of cross section. Okay. Now here, if I talk about a new term, so rate of flow of charge is current. Okay, which is given by I is equals to delta Q upon delta T, or this is the average current. This is termed as average current. And if you are want to know the current at a particular instant, then this is the value, that I instantaneous is equals to dq upon dt. For a very small change of time, very small value of charge will flow. So it is dq by dt. This is the instantaneous current. Okay. Now, if I talk about a new term, which is current density. Current density. And current itself is a scalar quantity. So current density is defined as current per unit area. This area is an area vector. So this current density written by J will be a vector quantity. So from this expression, if you see, I is equals to J dot. If you open this expression, then I will become J dot is JA cos of theta. So same in this example, if you will see, if this is the particular area of cross section and this angle is theta, so you have to take this component, which is A cos theta. This is A. Got it? So this component you have to select for the flow of current. Here J is the current density. And current density is a vector quantity. No. Direction of current. So conventionally we assume that direction of current is the direction of positive charge. Okay. So if this is the conductor, let's say conductor wire we have, and the positive charge is flowing in this direction, so the direction of current will be in the same direction of flow of positive charge, same as the direction of flow of positive charge. Hello Anu, how are you? Good evening. Okay. So direction of current is the direction of positive charge carriers. Okay. But generally what will happen in a conductor, the positive charge are very heavy ions, so they cannot move. Only the electron will move, which is negatively charged. Okay. So because of the flow of these electrons, the current has been developed. But at that time, we have defined the current, The electron was not discovered then. So that is why we assume that the direction of flow of current is the direction of flow of positive charge. And since we assume that the electron move opposite to the direction of positive current, because if positive charge is moving in this direction, so electron will definitely move in opposite direction. So I will write it, electron moves in opposite direction to the current. Okay. Now, Ohm's law, if we talk about. Hello, Pooja. Good evening. Good evening, Swapna. How are you? Is the screen is visible to you and I'm audible to you? Hello, Swati. Good evening to all. Make sure the screen is visible to you and I'm audible to you. If it is so, please give me a thumbs up. I have enabled the reaction part for you. So you can put this message on the chat box. Okay. Thank you, Pooja. Why you guys have joined late? It's already 17 minutes has been passed. Don't you know about the timings of the classes? Like I'm asking, I'm not, मैं कोई डांट नहीं रहा हूँ. I'm just asking to know. Don't you know about the timings of the class? It's from 3 p.m. to 4 p.m. No? Basically, it's from 3 p.m. to 3:55, but usually it take 1 hour. Okay, so no problem. Okay, okay, got it. हाँ वो मेरे साथ भी बहुत होता है. I got it. So no issue if I just revise you. I have not discussed so much. So today's our topic is current electricity. Hi Thashri, Thanushri. अरे आवाज तो बहुत बच्चे आ रहे हैं भाई. क्या बात है. So VI characteristic of ohmic and non-ohmic conductor we are going to study. Electrical energy and power, electrical resistivity, conductivity, temperature dependency of resistance and resistivity, galvanometer, ammeter, voltmeter. In EPER based, we are going to see some PYQs from JEE Mains and NEET. So let's get started. Initially, I have just talked about what is current. So you all know current is the rate of flow of charge. Actually, it's a rate of flow of positive charge per unit time. So I we have defined as two types: the average current and instantaneous current. Average current is delta Q by delta T. For instantaneous value, this charge has to be very low. So dQ, and for that time should be very low. It is dt. So this value of current is termed as instantaneous current. This value of current termed as average current. After that, we have studied about the current density. Current density is nothing but current per unit area. If you talk about the current density is a vector quantity, yet current itself is a scalar quantity. Okay, so current may you always remember that this flow of charge should always passes through the perpendicular to the cross-sectional area. So if this type of cross-section you have to resolve this cross-section into two parts, and only the perpendicular cross-section you will have to take. Okay, so this I is nothing but J dot A. J is the current density. If you open this expression, this is a dot product. So it is J A cos of theta. This A cos theta we have to take. If this angle is theta, So this would be A cos theta. So we have to take only the perpendicular component of area, or charge must be flown through the perpendicular to the cross-sectional area. Okay. So then we have discussed about the direction of current. The direction of current is usually we will take the direction of flow of positive charge. But there is a story behind it. When we discover or when we define the positive charge or current, then at that time we don't know, we didn't discover the electrons. Actually, the free electron generates the current. Because of the movement of free electron, the current would be generated. But at that time we haven't discovered this electron, so we assume that the current should be in the direction of positive charge flow. But you know, in conductor, positive charge are very heavy ions, they are not able to move. So that is why only electrons move. So we have already assumed that current should flow in the direction of positive charge. So nowadays we will say कि electron will flow in the opposite direction to the current. Okay? क्योंकि तब तक इलेक्ट्रॉन डिस्कवर हुआ ही नहीं था, तो we have assumed कि only positive charge is responsible for the flow of charge. So we have discussed that. After that electron has been discovered, then वो assumption हमने change करना सही नहीं समझा. We didn't feel good about that. So electron moves in the opposite direction to the current we have assumed. Hello Abhi. You have joined Abhi. Good. Now we are talk about the Ohm's law. So you already know, if this is the conductor of length L and area of this cross section of this conductor is A, and I have applied a voltage source around this, the voltage will be I. The current flown will be, voltage applied is V and current flows through this conductor is I. So we can say that the Ohm's law says that this voltage applied is directly proportional to the current flow. Okay, which means increase in the applied voltage, increase in the value of current flow. Okay, but there is a condition for this Ohm's law, that the length, area, pressure, temperature should remain constant. Which means these physical conditions or properties of a conductor should remain constant, then the Ohm's law will follow. And if you remove this proportionality sign, or you all know, you will get a constant which is nothing but the resistance. This is called the resistance of the circuit. Okay, got it? Now this is the form. This is a very simple form of Ohm's law. V is equals to I R. Okay, for 1 volt of current difference, 1 ampere current will be flown through 1 ohm of resistance. The unit of resistance is ohm. You can write it as like this or this. Okay. Now, if I talk about the VI characteristics of ohmic and non-ohmic conductor, so it should be, and firstly I will discuss something about the resistance. Okay. So the formula for resistance, we know that resistance varies according to the length, directly proportional to length. Resistance is 1 by A, proportional to 1 by A, which means for area, it follows the relation inversely. If you increase the area of the conductor, the resistance would decrease. And the reason for that, if you increase the area, let's say this is the area 1 and this is area I. So if you have increased the area, the large number of charge will flow through this. So if the number of charge will increase, definitely the current will increase, so resistance will decrease. Okay. So if you combine this formula, you will have R is directly proportional to L upon A. If you remove this proportionality sign, you will have R into rho L upon A, where rho here is the resistivity. Resistivity. Okay. This is the property of material. This rho is the property of any material. Like material is made up of aluminum, copper, and all. So these material has a specific value of resistivity. Okay. What we have to do for measure the resistivity? We will keep the resistance 1 ohm. We will take the 1 meter length of that conductor, 1 meter square of the area, then 1 ohm resistance. How much resistivity will be provided? Then we will calculate that. Okay. So this is just for your knowledge. This formula is very important. R is equals to rho L upon A. Now, so VI characteristic of ohmic and non-ohmic conductors we will firstly see. Ohmic conductor क्या होते हैं? The conductor which follow ohmic conductor. The conductor that follows the Ohm's law. Conductor that follow Ohm's law is called as ohmic conductor. Okay. And what is non-ohmic? So you will understand what is non-ohmic, which does not follow the Ohm's law, but they are conductors. Okay. The conductor that does not follow Ohm's law, that is to be said as non-ohmic conductor. So if you talk about the ohmic conductor, they are following the Ohm's law. So VI characteristic means the graph between V and I. We will see that what is the variation of the voltage and current for ohmic conductor and for non-ohmic conductor. That is the characteristic. Basically, we are going to draw the graph between V and I. We will vary V or I, and then we will see the variation on that. Okay. So let's say for this is for the ohmic conductor. Ohmic conductor. Now this is V and this is I. We know that Ohm's law is nothing but V is equals to IR, or we can say V is equals to R into I. Now R is a constant, so this is similar to Y is equals to mx, where m is a constant and is the slope of the line, and x and y are the variables. So this is a straight line passing through origin. Okay, so from that relation we can say that VI characteristic will be a straight line for ohmic conductor, and this theta is nothing but R. Okay, theta here is equals to m is equals to tan theta, which is equals to R. Okay, now for non-ohmic conductor, VI characteristic would be non-linear. This is V and this is I. Okay, this is a non-linear relation for non-ohmic conductor. Non-ohmic conductor. Got it? So remember these graphs. For ohmic conductor, it is a straight line between V and I. And for non-ohmic conductor, it is a what? It is a curved line. Okay. This is not a linear line. One thing you should note, if you increase the temperature of ohmic conductor, this will also start disobeying the Ohm's law, which means it start acting as a non-ohmic conductor with the increase in resistance. Got it? And what is that kind of semiconductor? That kind of conductor is called, although I have revealed the name, it is called the semiconductors. You have seen, na? I have taught you about semiconductor, they will follow this kinds of relationship. VI characteristic we have seen, and before also. This is called the cutoff voltage or knee voltage. Got it? So in semiconductor, what we are doing, we are heating it so that more electrons should reach in the conduction band. Make it a conductor behaving like a conductor. So that is happening because of the increase in temperature. Okay. So ohmic conductor, a particular semiconductor will behave as a non-ohmic conductor. Got it? So these two relation you have to follow in your mind. That for ohmic conductor is a linear relation, non-ohmic conductor is a curvilinear relation or non-linear relation. Now what happens when an electric field is applied across the conductor? So let's say this is the conductor and we have applied an electric field towards this. So what will happen? This electric field, let's say the length of this conductor is L. So this electric field will generate a potential difference because we know V is equals to EL from the relation of dV is equals to minus E dot dr. And we are not interested in the sign, negative or positive, only in the magnitude. So that is why I have written this. So V is equals to EL. Okay. But what is the hack here? That for metals, conductor are usually we take metals. So for metals there are free electrons. Free electrons की वजह से क्या होगा? Electrons. So these free electrons, in the absence of electric field, also wandering, like they are moving in to and fro direction. If this is the conductor, these are the free electrons. They will also move because of the thermal agitation or thermal vibration. They will move randomly and vibrate their own axis. Okay. They will move randomly. Why? Because of the kinetic energy that is gained by the temperature. Because we know according to kinetic theory of gases, the kinetic energy will be given by 3 by 2 times kappa into T. This is, let's say, kappa. Kappa is a constant. Or you will say it's a kb into T. Kb is a Boltzmann constant. So you can see here this kinetic energy directly proportional to the temperature, which means the kinetic energy of a particular atom inside a conductor will be zero when temperature is zero Kelvin. And that is not possible. Okay. Absolute zero temperature is not possible, which means that in the absence of any external field, they also have some kinetic energy. Okay. But the motion of electron is such that they are so random, they will cancel out the effect of each other, and the net current or the net potential difference inside the inside the conductor will be zero. Electric field would not develop inside it because of the random motion of electron. But when we apply electric field by a battery, so we are saying indirectly that we have applied a battery of a potential difference that would develop an electric field and apply a force in the direction positive to negative. Now electron will feel a force because of this electric field. We know if there is a charge in an electric field, it will feel a force. F is equals to QE. And if Q is electron, so it will taken as E into E. And we know that electric field apply a force in the opposite direction of it to the electron. So electron will move in the opposite direction to the applied electric field. So now these electrons will align themselves, although they are moving randomly, but they will feel a force in the opposite direction to the electric field. This is same as if there is a river which is flowing downstream and you put your shoes, you are wearing your shoes and then put your leg inside that river. So you will feel a push. You will feel that river want to take your leg. Okay. in a particular direction from in the direction of flow. So what is that? The river is flowing from high altitude to low altitude. So that is why a pressure difference is there. Because of this pressure difference, this water current has been developed. Same in this, in the case of conductor, because of the potential difference by the applied electric field, because of that potential difference, the electron would feel a force, which we usually called as electromotive force. An electron will move in opposite direction to that. Okay. Also, they are moving to and fro. If you take the example of a boat, and here, if I draw a boat here, this is a boat, let's say, and this want to try cover this, cross this river. Okay, here we want to reach this point, and the river is moving in this direction. So what would happen? Meanwhile, in the journey, we are directing toward this point, but we will reach at this point somehow distant from this point, and this value is called as drift. How much we have drift from our initial position, sorry, the original position, that is called a drift. And this drift came because of the flow of current, flow of water current. So same in the case of a conductor, the electron is moving randomly because of the kinetic energy got thermally 3 by 2 kb into t. But because we have applied electric field to that conductor, so electron would force to move in the field of direction. They are moving randomly or moving away, so they will drift. We will say the electron will drift in the direction of applied electric field. Okay, so that that velocity or the speed at which the electron would drift is called drift velocity. Drift velocity, and it is nothing but minus E electronic charge applied electric field divided by mass of the electron into tau. Now what is this tau? This tau is relaxation time. Relaxation time. Now what is relaxation time? So these electrons, when they are drifting, they will collide with the another positive charge or the another electron. They have a tendency to collide. So this time is the average time between two successive collision. Like अभी ये भिड़ा इलेक्ट्रॉन, इसके बाद ये चल दिया, अब दूसरी जगह जहां पे टक्कर होगी, इस टक्कर से उस टक्कर के बीच का जो टाइम है, the average time, we will take more of the takkars, more collision we have taken, lots of collision, and then we calculate the average time of that, and which is termed as tau, which is relaxation time. Got it? So this drift velocity is represented by Vd. So Vd here is minus E capital E upon M into tau. Why it is minus? Because of the electric field. They will move in the opposite direction to applied electric field. Got it? Now, current formula, if I talk about in the microscopic term, the discussion that I have did in the previous slide, it is the discussion for microscopic level of current. Okay, we are understanding that how the current has been developed at microscopic level. Got it? So the formula that should be followed here is I is equals to N E A V D. In the previous slide, if you have any kind of doubt, you can ask anytime, any kind of doubt you have. Okay. Do not wait for me to say you ki, please ask the doubt. Okay. If you have any kind of doubt at any particular instant, you will instantly write this in the chat box or raise your hand. Got it? Now here N is nothing but the number of free charge per unit volume. Number of free charge is nothing, the electrons. That is the free charge. Na? So it is also termed as number density because it is number per unit volume. Density is nothing but mass per unit volume. Okay, so it is number density, and that is called mass density. So number density, it is a number density. Vd is the drift velocity, a is the area of cross section, this. And let me change the color. This is the area of cross sectional area. Okay, and from here you will also say that I have teach you another term, which is current density. Current density is nothing but I upon A. So it will become NeVd, where E is the electronic charge. Got it? Now, finding resistance. So I have already found it for you. If the length of this conductor is L, area of cross section is A. So we can say that resistance is nothing but rho L upon A. Got it? Now, this is a question of JEE Main 2023. So try to solve it. Giving you 1 minute. Very easy question. A wire of resistance 160 ohm is melted and drawn in a wire of 1/4 of its length. The new resistance of the wire will be. Okay. So let me tell you two formula or two trick. And that is not a trick. That is the conceptual thing that I have derived. If length of conductor is increased by n times, n times. So if length is increased, you will see in the relation, if length is increasing n times, the resistance will also increase. Okay. So the resistance would become n square time, R dash is nothing but n square time the previous resistance. Okay. And if length is decreased by n times, so this ratio would be reverse, R by n square. If length decrease by n times, and from where it come? If you increase, let's say, the length of the conductor n times, so L dash is nothing but n times L. Now, what about area? Area will also be effective. Okay. Area will also play a role. So we know that the volume of this conductor remain constant. So volume initial is equals to volume final. Initial volume is area into length. Let's say the length is small l. And final, V final is A dash into L dash, and L dash is nothing but NL. This L and L will cancel out. So A dash is nothing but A upon N. So A dash we have also calculated A upon small l. Now R dash is rho L dash over A dash. Put the value. L dash is NL divided by A dash is A by N. This N will go up. So resistance that you would have as rho L upon A into N square. And this rho L upon A is nothing but the initial resistance. Similarly, if you take it L by N, so this area will become Na. So it will reduce by n times. Now, look at the question. A wire of resistance 160 ohm is melted down in a wire of 1/4 of its length. यानी कि लेंथ इज डिक्रीजिंग हाउ मेनी टाइम्स, 1/4, यानी कि वैल्यू ऑफ n विल बी 4. Got it? Look, initially the length is L. The L dash will become L by n, and n is equals to 4 because it has become L by 4. So if it is decreasing n time, so resistance would decrease by n square time. So R dash is R upon n square. R is nothing but 160. N square is 4 square, which is 60. So it will become 10 ohm. Option D is correct. Look how simple is this. Instead of going on to this volume constancy and all, you directly apply this formula and get the answer and save your time. Now, this a copper wire is stressed to make it 0.5% longer. Length has increased, but in terms of percentage. So delta R by R is given to you. Delta R by R into 100 is given to you as 0.5. So remember this formula. R is equals to rho L upon A. Now, if the volume remain constant, so R is only dependent on length because length is only the factor that has been changed. There is nothing about the area. So we would have to replace this area by length. We know that volume is nothing but area into length. If you talk about the value of area, it is volume per unit length. So it will become volume per unit length. So R would become rho L square upon A. Now rho N is rho upon V. And rho and volume is a constant. So R is directly proportional to L square. So delta R by R will directly proportional to, will equal to, I will say, 2 times delta L by L. Apply this here. Delta R by R into 100 is equals to 2 times delta L by L into 100. So delta L by L is given to you as 0.5. So 2 into 0.5 will become 1%. Got it? Now, another form of Ohm's law. What is that and where it has come? So we know that I is equals to NEA VD. VD is the drift velocity. If I say that I upon A is NE VD, put the value of VD. I upon A is NE VD is E capital E upon M into tau. I upon A is nothing but J is equals to NE square capital E upon M into tau. Now these all quantities, NE square upon M into tau is a constant one. So J you can say is directly proportional to E. This is the another form of Ohm's law. J is the current density. E is the applied electric field. In that case, V is the applied voltage which has already derived it from this. Got it? And J is the current density which is related to current. You can also derive it from this formula. Rho R is equals to rho L upon A. Got it? And V is equals to IR. V is equals to I into R की value rho L upon A. ठीक है? You can take this V by L, I by A into rho. Now V upon L is nothing but, we know that electric field multiplied by length is equals to voltage applied. So we can replace this V by L by this applied electric field, which is equals to I by A is J into rho. And rho is the resistivity. So same form is the Ohm's law. Voltage applied या electric field with current density into resistivity. V is equals to IR. The same form is this. Got it? Now, so this form has like, V is equals to, sorry, E is equals to rho into J. This is the another form of Ohm's law. Now the temperature dependency of resistor. Okay. If you increase the temperature, what will happen? If you increase the temperature, the resistance would decrease because the resistivity decrease. We know that from here, if you will compare I upon A is J, which is Ne square M upon M into tau. Okay. J is equals to Ne square tau upon M. Okay. Into E. So what is this? This is rho. E is equals to rho J. So E is equals to rho into J. So J would be E upon rho. So this value is nothing but 1 upon rho. 1 upon rho is Ne square tau upon M. So rho would be Ne square, just a second, M upon Ne square tau. Now, if you increase the temperature, the relaxation time will decrease because now the electron will vibrate more vibrantly with more kinetic energy. Increase in temperature, increase the kinetic energy. So electron now will vibrate more. So the time of collision between them will decrease. So if this value decrease, the resistivity will increase. One of the formula sigma, which is 1 upon rho. Sigma is the conductivity. Okay. So if resistivity increases, conductivity decreases. Got it? And it is directly proportional, showing if you increase the temperature increase, so resistivity would decrease. Got it? So we can say that the resistivity is equals to rho naught, original resistivity, 1 plus alpha T minus T naught, where rho naught is the resistivity at temperature T naught. So this formula you can remember. And another formula for resistance, because resistivity is directly proportional to resistance. So same way you can write R naught 1 plus alpha T minus T naught. Now, this alpha is the temperature coefficient. Okay. This alpha is the temperature coefficient of conductor. It is the temperature coefficient. Now, RT graph we will draw and then we will see a numerical. RT graph is nothing but the resistance temperature graph. So for metals, I will draw it. If I draw it for metal, this is R and T. This will follow a non-linear relation. Increase in temperature, increase in resistance. For non-metal and semiconductor, it is same. So for semiconductor, and why it is happening? Because resistivity is directly proportional to 1 upon tau, which is the relaxation time. So if you increase the temperature, the relaxation time between the collision will decrease. So resistivity will increase. Now, the same thing for semiconductor, if I talk about. Semiconductor के लिए क्या होगा? So same thing would be followed, but the graph will be drawn like this, which means increase in temperature, decrease the resistance. Why it is happening? You know that in semiconductor, there are bands, conduction band and valence band. So initially there is no electron in the conduction band. If you increase the temperature, if we supply the energy to semiconductor, the number of electron or the electron density in the conduction band would increase. Although the relaxation time is also decreasing, which is a crucial factor, because if relaxation time decrease, it will increase the resistivity. But here the number density of electron is higher is higher than what? Than tau. So increase in temperature, increasing the number of charge more significantly than decreasing in the tau. So resistivity will, or the resistance would decrease for semiconductor. Got it? Now, color coding. This is a very simple topic, and you can accept one numerical from this. So in this, you have to. I have made a abbreviation for you. So there are colors in this, and you have to start reading from here to here, from left to right. Okay, first digit, second digit, and then see the third color will be for the multiplier, and the fourth color will be the tolerance. So how would you write for this? These are the colors, these are the coding according to them. So to remember this, we have learned this abbreviation, which is BB Roy in Great Bharat has a very good wife, which automatically demands for Sona Chandi, gold and silver. And after that, it is no color. So B represent black. Again, B is for brown. Roy, R is for red. O is for orange. Y is for yellow. G is for green. B again is for blue. And V here for violet. G for gray. W for wife. And gold, silver, I have written it. So BB Roy in Great Bharat has a very good wife, demand for Sona Chandi or gold silver. So how do you write it? Look, here the first color you will say, what is this? Let's say this color is, what will you find in this? Let's say this color is brown. So for brown, the digit is 1. So write 1. Again, the color, next color is black. So for black, what is the digit? It is 0. So write 0. Write 0, 1, 0. Then you have to multiply it with this color. This is, let's say, orange color. So for orange, it is digit 3, but the multiplier is 10 raised to the power 3. So you have to multiply it with 10 raised to the power 3. And then you have to mention the tolerance. So this color, let's say, is gold. So for gold, the tolerance is 5. So you will say that it is plus minus 5. So this is the value of this resistor. This, how easily you can find this. Okay, got it. So for power, if I talk about very quickly, because it is a revision series, so we know that V is equals to IR. Okay, V is nothing but the work done by conservative force. We have done that per unit charge. Okay, so work done, if you talk about, it is equals to the potential energy, and potential energy is nothing but Q into V. Got it? So if you divide the work done, if you calculate dW by dt, so it will be dQ by dt. dQ by dt is nothing but the I. Flow of charge per unit time is I into V, or you can say VI. So VI is the power. Rate of work done is power. If you replace it by only R and VI, so put the value of V is equals to IR. So power will become I square R. And if you replace this I with V upon R, the power will become V square upon R. Okay. Now, what is electrical energy? Electrical energy is nothing but the potential energy, which is U is equals to Q into V. Okay. Q is equals to, you can write at I is equals to Q upon T. So Q is equals to IT. So U is equals to, put the values I T into V. So it will become VI into T. Put the value of V. IR, so it will become I square R into T. This is the electrical energy, or you can say the heat loss in the conductor. Got it? Now this we will discuss in the next class. Okay. So if you have any kind of doubt right now, till now, you can ask. Otherwise, the lecture is being over. Thank you so much for being attentive. Take care of yourself and be attentive in the lecture and join at the timing of the classes. Okay, at 3 p.m. sharply. Got it? So thank you so much. Uh, any kind of doubt you can ask. Otherwise, you can leave. The chapter is being over. Not the chapter, the lecture is being over. Thank you so much.